Welcome to the video of the first part of Stage 4 on your learning unit Management of Forms and Spaces. In Stage 3, we studied the right triangle and trigonometric radius for acute angles. In this stage, we will see angles in Cartesian plane and trigonometric radius for any angle. So let's begin. Cartesian plane is formed by two perpendicular lines, an horizontal and a vertical. These lines are cut in a point. The horizontal line is called x-axis. The vertical line is called y-axis. And the point where both lines are cut is called the origin. These lines form four regions called quadrants. These quadrants are numbered in counterclockwise form, starting at the upper right quadrant. Into the plane, you can locate points, which are formed by ordered pairs as x, y. These ordered pairs are called coordinates. The signs of each coordinate are established according to the quadrant. On quadrant 1, the values of x and y are positive. On quadrant 2, the values of x are negative and the values of y are positive. On quadrant 3, the values of x and y are negative. And on quadrant 4, the values of x are positive and the values of y are negative. When there is a point in the Cartesian plane, we can determine the radial distance r. This is the distance between the point and the origin. And because this distance is not directed, it implies that its value is always positive. To calculate this distance, we will use the Pythagorean theorem, because a right triangle is formed. That is, the distance from the origin to x is a leg, the other leg is height y, and r is the hypotenuse. So, r squared equals x squared plus y squared, and r is the square root of x squared plus y squared. According to this, we can say that three values are associated to a point P. Those values are x, y, and r, but an angle is also associated. The angle associated to a point in its standard position is an angle with vertex at the origin, its initial side lies in the positive section of x-axis, and its terminal side is the ray r that passes through the point P. It exists an infinite number of values of an angle that can be associated to a point P, because if it turns all around, it will reach the same terminal side. One more spin, and it will reach again the same terminal side, and so on. These angles are called coterminal. They have different magnitudes but the same terminal side. For example, the angle 86. If we spin it once, we are adding 360 degrees to it. Then the coterminal angle is 446 degrees. If we add again 360 degrees, then other coterminal angle to 86 degrees is 806 degrees. And if we do the same again, then other coterminal angle is 1166 degrees. And we keep doing this to obtain more coterminal angles. For angle 803, a coterminal angle is 143 degrees. That because we also can subtract 360 degrees to determine a coterminal angle. 863 degrees is a coterminal angle to 803 degrees. Because 503 degrees plus 360 degrees is 863 degrees. Another coterminal angle is 1223 degrees, because once again, we add 360 degrees and 863 degrees plus 360 degrees equals 1223 degrees. Now, not every angle has its terminal side in quadrant 1. If we have an angle that in its standard position has its terminal side on the second, third, or fourth quadrant, we can see it from its reference angle. The reference angle is a positive acute angle between x-axis and the terminal side R. That is, the angle that is closer to x-axis. Let's see. We have the Cartesian plane. Let's locate 0, 90, 180, and 270 degrees. On the first quadrant, we have, for example, the angle 42 degrees. This is an acute angle, and it is the one closer to x-axis. But if we have the angle 125 degrees, its terminal side is on quadrant 2. Its reference angle is the one formed between the terminal side and the negative x-axis. That means that is the angle closer to x-axis. So, in this case, the reference angle is 55 degrees. Because between 125 degrees and 180 degrees, there is a difference of 55 degrees. The angle 200 has its terminal side on quadrant 3, and the angle that is closer to x-axis is 20 degrees. So, this is its reference angle. That is because between 200 and 180, there is a difference of 20 degrees. Now, let's see the angle 294. The terminal side is on quadrant 4, so the angle closer to x-axis is the acute angle 66 degrees, because between 360 degrees and 294 degrees, there is a difference of 66 degrees. As a summary, the value of the reference angle depends on the quadrant where the terminal side is located, considering the angle between 0 and 360 degrees. On quadrant 1, the original angle and the reference angle are the same. On quadrant 2, the reference angle equals 180 minus the original angle. On quadrant 3, the reference angle equals the original angle minus 180 degrees. And on quadrant 4, the reference angle equals 360 degrees minus the original angle. Let's see then the trigonometric radius for any angle. Let's go back to the Cartesian plane and let's consider an angle in its standard position, as well as a point in which terminal side passes through. Now, let's draw the radial distance, the distance on x and the height on y. As you can see, we have again a right triangle. So we can determine the trigonometric radius in terms of x, y, and r. So, as sine of the angle is defined by opposite leg over hypotenuse, now in Cartesian plane, sine is defined as y over r. Cosine is defined now as x over r, because x is the adjacent leg and r the hypotenuse. Tangent is then defined as y over x, because it is opposite leg over adjacent leg. Cosecant is r over y, because is the reciprocal of sine. Secant is the reciprocal of cosine, so it is defined as r over x, and cotangent is x over y, because it's the reciprocal of tangent. All this is considering the first quadrant. However, if the angle is on a different quadrant, then we just have to consider the signs of x and y. Remember that r is always positive. Let's see an example. We have to determine the trigonometric radius of angle theta if its terminal side passes through the point minus 6,8. So we have that x is minus 6 and y is 8. To obtain the radial distance, we apply then r squared equals x squared plus y squared. So, r equals the square root of x squared plus y squared. We substitute the values of x and y, so r equals the square root of minus 6 squared plus 8 squared. And that equals the square root of 100. Then the radial distance is 10. Once we have obtained the values of x, y, and r, let's form the trigonometric radius for angle theta. Sine of the angle equals y over r, that is 8 over 10, and simplifying equals 4 over 5. Cosine of the angle is x over r, that is minus 6 over 10, and simplifying minus 3 over 5. And this must be written as negative 3 over 5 because the sign is for all the fraction. Tangent of the angle is y over x, that is 8 over minus 6, and simplifying is 4 over minus 3, and it must be written as negative 4 over 3. Cotangent is the reciprocal of tangent. That means that cotangent equals minus 3 over 4. Secant of the angle is the reciprocal of cosine, so it equals minus 5 over 3. And cosecant is the reciprocal of sine, so it equals 5 over 4. Now, as you can see, some trigonometric radius are negative. The signs associated to the values of trigonometric functions of an angle depend on the quadrant where the terminal side of the angle is located. If the terminal side is on the first quadrant, the values of x and y are positive. Remember that r is always positive, so all the trigonometric functions are positive. When the terminal side of the angle is on the second quadrant, the value of x is negative, so the trigonometric functions where x is involved have a negative value. Then, sine and cosecant are positive, cosine, tangent, cotangent, and secant are negative. When the terminal side of the angle is on the third quadrant, the values of x and y are negative, so sine, cosine, secant, and cosecant are negative, and tangent and cotangent are positive. That is because x and y are negative, so the result of the division is positive. When the terminal side is on the fourth quadrant, the value of y is negative, so sine, tangent, cotangent, and cosecant are negative, and cosine and secant are positive. So, as a summary, the signs of trigonometric functions are defined according to the quadrant where the angle is located, as is shown in the chart. Let's see an example considering the quadrant where the terminal side of the angle is located. Find the values of all the trigonometric radius for angle theta if its terminal side is on the third quadrant and its cotangent is 7 over 24. We know that the terminal side of the angle is on the third quadrant. Besides, we know the cotangent, which is defined as x over y. So, even if the cotangent is positive, the values of x and y are negative on third quadrant, and negative divided by negative equals positive. Then, x equals minus 7 and y equals minus 24. Once we know the values of x and y, we can calculate the radial distance. So, r equals the square root of minus 7 squared plus minus 24 squared. Then r equals the square root of 49 plus 576, and that is the square root of 625. We have then that r equals 25. Let's form now the trigonometric radius. Sine of the angle equals minus 24 over 25. Cosine of the angle equals minus 7 over 25. Tangent of the angle equals minus 24 over minus 7. That is equal to 24 over 7. Cosecant of the angle equals minus 25 over 24. Secant of the angle equals minus 25 over 7. And cotangent of the angle equals 7 over 24. As you can see again, the signs for the values of trigonometric functions depend on the quadrant that the angle is located. Now, let's go back to the concept of reference angle. So let's see the following definition. Any trigonometric function of an angle has an absolute value equal to the value of its angle of reference. It means that the absolute value of sine of an angle equals sine of the reference angle, and is the same with the absolute value of cosine of the angle that is equal to cosine of the reference angle, and the same with the other four trigonometric functions. The sign associated with the value of each trigonometric function is determined according to the quadrant in which the terminal side of the given angle is located. This definition will help us when we have to determine the value of the angle when it is known the value of a trigonometric function, because it means that there are two angles between 0 and 360 degrees for every value of a trigonometric function. Let's see the following example. Find the value of theta such as this angle measures more than or equal 0 but less than or equal 360 degrees if sine of theta equals minus 0.309. First, we need to use the chart that we saw previously to check the quadrants where the angle is located according to the sign of the function. In this example, sine is negative. That means that one angle is on quadrant 3 and the other angle is on quadrant 4. Then, we apply the inverse of sine of the absolute value of minus 0.309. That is the inverse of sine of 0.309, and that equals 18 degrees. This angle is then the reference angle. So, for angle that must be on third quadrant, we have to add 180 degrees plus 18 degrees, and that is 198 degrees. And for the angle that must be on quadrant 4, we have to subtract 360 degrees minus 18 degrees, and that is 342 degrees. So the angles that fit on the condition that its sine equals minus 0.309 are 198 degrees and 342 degrees. We have finished the first part of stage 4. As a summary, we have seen so far angles in Cartesian plane, coterminal and reference angles, trigonometric radius in Cartesian plane, and how to determine an angle according to the value of a trigonometric function. Don't forget to solve the learning activities on your textbook to practice the contents included in this video. Have a nice day and see you soon.